Hello everyone, my name is Azad Anil Meshram and I have worked on the Yes Bank stock closing price prediction. Basically, it is the linear regression project which predicts the closing price of Yes Bank's stock. This is the problem statement which says कि according to these the available independent variable, what should be in the future could be the closing price of the Yes Bank stock. These are the important libraries which I have installed for the project. The Plotly for plotting the graphs, mounting the drive, and this is the first look of the dataset. It consists 5 features: date open, opening price, the highest price of the stock, lowest price, and the closing price. The closing price is our dependent variable, and these rest of the features are our independent variables. It consists 5 columns, it consists 185 rows. It do not consist any duplicate value, it do not consists the null values either, and this is the representation visualization of missing values. Basically we could see each and every feature is showing the 185 data points. These are our columns, and this is the describe functionality of the pandas. So we could see here minimum value is 10. That it means in the opening price of the Yes Bank the minimum price is 10, but its maximum price is 369. So we could see here somehow it has increased in a leaps and bounds manner, and we could at least guess here okay, if there is some kind of cliche thing which have occurred here, we cannot consider here it as an outlier, because it might be possible that is the real, or that is the real time price of the Yes Bank stock. So we could consider here okay, some kind of manipulation or some kind of investment dumping have occurred in the Yes Bank stock so that the price could skyrocket. These are the variables description, we have already discussed it. These are the this is the unique value functionality. We can see at least every feature is showing the same value. So we could say here okay, each and every value or each and every data point of the features is unique. This is the user defined function, and this function is helping me to calculate the outliers in the individual features. This is the 25th percentile in via this particular thing. I'm calculating the 25th percentile of the feature 50 and 75 and calculating the interquartile range and putting these 4 values to calculate the lower limit and upper limit of the feature. This functionality is giving the outliers to me. Later on, this is the I have copied this particular data set for another things, for like comparing all the 4 features: open, high, close, and low, all the features to compare with its date, so that we could see on which particular date which data point have skyrocketed, or whether it is balanced, or whether it is maintaining its trend, or it is just have increased. So I have unstacked it and we have visualized it in the data visualization section. Again, mean of the dataset and median of the dataset. Why I have considered these two things? Because mean is the average of all the values, and we know this thing mean could be manipulated by the outliers, by the highest values. For here, the outliers are those values which are the output of the manipulation. Let's say there is a stock, for example Yes Bank here only. Yes Bank might be have manipulated by certain kind of news or any kind of particular objects. So if it is manipulated, we could see here there should be a difference between its middle value and its mean value, because the middle value will show a balanced middle thing in which the half of the values are one side and half of the values are other side, but mean will consider those high values also. So we could see the mean of the open is 105, but median of the opening price is 62. So we could see here कि somehow the stock prices have moved very drastically from its median to achieve this much of high mean, and we will represent this in the data visualization section for getting the maximum and minimum values of all the features. So this functionality is letting us aware that what could be the maximum, what is the maximum value of opening price of the Yes Bank, and what could be the minimum price, what could be the minimum opening price of that particular stock. We could see opening prices, maximum opening price is 369. Let's say on in the round figure it is 370, but minimum price is 10. Yes, we could. Here the point is the data set is flowing from 2005, 2006 to 2020. So we could at least expect this thing, but we also have to consider this thing ki whether this trend have achieved very drastically or whether it is a gradual change. So we will see in our data visualization part. So basically here only I have just plotted a distribution plot for every feature: open, high, low and close. This is by observing this distribution plot we could see okay, distribution is maintained and distribution is similar in all the features. The next thing is I have tried to transform that particular those particular features in order to see whether it will show the normal distribution or not, and here the log function is helping us to achieve this normal distribution in these features of the data set. And yes, normal distribution can be observed very clearly in the chart 3. Now so far we were discussing key middle value and the mean value. From this chart we could easily see key middle value might be somewhere here, but mean value might be somewhere here. Why? Because of these high rockets, because of these high peaks, high mountains. Somehow Yes Bank have achieved this high or greater pace in a meantime. So that's why the mean is drastically increased. If this change would have been appeared gradually in the stock of Yes Bank, the mean might not be this much far from its median, but this change is very much observed significantly from 2016 up to 2018, these 2 years. Now compare this thing to the history of Yes Bank from 2005 to 2020, 15 years, and there were only 2 years where the high prices have been observed in the stock price of Yes Bank, and later on we could see it is achieving the lowest of lowest in its history. So this might be happen. This we could say this have achieved in August 20. Might be possible ki the effects of COVID or something else, but we could see ki this the prices have started to escalating down. So this trend can be easily observed by this particular visualization. Later on this is the mean. We could see ki this is the mean of the data set, and in comparison with this, what we have to do, we have to bring in on the platform this median chart also. We could see the opening median price is 63 and opening mean price is 106. Again the same thing, the very drastic change from 63 to 106. This is something which is observable. This is something which we could, by seeing this thing, we could observe there is something which is manipulating or which is creating a very overnight success for the Yes Bank stock price. Later on, these are the box plot to show the outliers in this in the particular feature. And now this is the very important matrix. By observing this, we could see there is a strong correlation between each and every other features. By convention, by our linear regression assumptions, we know that there should be a relationship between independent variable and there should be a relationship between dependent variable. So this relationship between dependent and independent variable is expected, but this chart is showing that each and every other feature also having a linear relationship with them. It shows there is a high collinearity in between them. But again, the data set is very small. There are very less number of data points. So, and another thing is that this is the stock market's price. There might be a very strong correlation, and it is very obvious that the opening price and the highest price or the lowest price might have the correlation. For example, let's say Indian Energy Exchange stock is opening on 520 rupees. Let's say, for example, 520 rupees. It has skyrocketed up to 560 rupees, but still it is closing at 520. So opening price and closing price, a strong bond. That is also a 520 value. It is also showing a 520 value. So stock market could show a very strong relationship. This is the same thing, the correlation heat map, which is showing the relationship between the features. Okay, now hypothesis testing. So for this data set, I have considered the hypothesis, null hypothesis, which basically says that let's say there are 200 data points, or let's say there are 200 closing price values we have, and my null hypothesis is saying that okay, where the closing price is, where the stock have closed, that price is mean, or either it is mean or it is more than the mean, and the proportion of this particular relation is more than 50% of the data points, total data points. Means if there are 200 data points, it might be, null hypothesis is saying that at 100 or more than 100 points, the closing price of Yes Bank stock is more than its mean price. So this is basically my null hypothesis. And this is the, okay, 0.3 is my proportion value. Now we could read this. This is the proportion of random sample which we have taken from our data set, shows proportion of, okay, so this should be changed. Okay, shows proportion of closing price where the price is more than its mean. I should be running this. Okay. So this particular thing is saying that 0.3% is the proportion of our random sample where the mean is, I would say, where the closing price is above its, where the closing price is above its mean. Means we could say कि closing price for this particular random sample is above its mean only for 30% of the data points. So let me run this. Probably it should not be giving me the error. Okay, now this is the proportion of random sample, shows proportion of closing price where the price is more than its mean. Means the closing price is more than its mean, and that proportion is only 0.3%. This is our p-value. Z score is something this, p-value is something this, and the statement says null hypothesis can be rejected as p-value is lower than significance level of 0.05. Now here we come to this conclusion that null hypothesis cannot be accepted. Why? Because the data points, the closing price, where it is closing at above its mean are not above than 50%. And we could cross check this thing via this functionality, and it says out of the total closing price only 0.33 means 33% are the values which are closing above its mean. So this is cross checked. Now let's go towards feature engineering. We see that there are no missing values. This is the function. I am calling out this function which I have already defined for myself, and it shows, and it has just changed or replaced the outliers by a null values. So we checked again the null values so that we could get the glimpse of the outliers present in our data set. It shows open has 9 outliers, high has 5 outliers, low has 9 outliers, close has 9 outliers. So is null is not something which is giving us the null value, because in our user defined function, okay, let's go here. In my user defined function, I have replaced the value which is outlier by null value. So that's why here, for finding the null value, what I am doing, for finding the null value, for finding the outliers, I am calling the null value function, so that it gives me the idea about about the outliers. Now I'm replacing those outliers by median, so that it should give me a balanced data set. So this is the feature correlation again. Now this is something which I have done for my feature engineering, so that I could change this date format into certain kind of numeric value. I have done this for separating this particular data point via hyphen, and I have replaced this July as 7 and 5. I have segregated it and considered those as values for my linear regression model, and its output will show like this: July will considered as 7, August will considered as 8, September 9, so that it would help me to better perform my linear regression model. Data transformation. So for transformation, I have used this functionality, that wherever the difference between mean and median is more than 0.1, that would be my skew symmetric. That would be my skew symmetric feature, and I have got these 4 features as my skew symmetric. But while I treat this, I have treated them by my log transformation, functionality, and we could see now skew symmetric columns are vanished, they are treated. Again, now I have replaced the actual value by the log transformed value, and again see that is there any correlation between them or not. Now I have defined what will be my x and what will be my y, using train test splitting the data set into training and testing and scaling them. And now the most important part of our project, the machine learning algorithm implementation. So I have, first of all, as my first model, I have implemented linear regression and observed that what would be my accuracy while using the R2 score. We can see here my test accuracy is 93%, which is pretty high, not good, it is very high. Why? Because the data set is small, obviously. And okay, this is the data visualization. The blue line is my predicted line, and actual line, and yellow line is my actual line. So we could see, of course, 93% will definitely show this overlapping and parallel trend with the actual value. This is obvious. Now the model 2, I have used lasso. I have checked this thing for 0.1 key, what could be the result. So I got the 93% again. So in the first model, I got the 93.96%. At the lasso regression, or I would say lasso regularization, I got the 93.75%. So a little less. Now let's go for the cross validation. What could be the results of cross validation and hyperparameter tuning? We saw that we got this alpha as our best thing, because we have used these values of alpha as our parameter and used the grid search cross validation by fragmenting our data set in 3 folds. CV is equals to 3, and we could see not so much of improvement. Like, we also know this thing ki after 93%, what else we could expect as our accuracy. Still it is giving the 93%.53. so now we could see at first it was 93.96, and at our first model 93.96, at our second model it was 93.75, yes, and at our third model it was 93.57, 93.53. so we could see a little bit downward trend in our accuracy. So but at last it is very high already, so it is still good. This is again a visualization for our testing and for our y-test and predicted values, our actual values and our predicted values. Now the ridge regularization. For ridge regularization I got 94% accuracy. When I have done its cross validation, actually the accuracy have decreased. So first of all it was 94.18%, but later on it has decreased to 93.96. Not that much reduction in accuracy, but still for our study we could say ki yes, the accuracy have decreased. So at this particular point we could consider our best model as this only, without any regularization. And the third, this is again for ridge regularization, the visualization of y-test and its predicted values. So, and the last, the model 3, I have used very advanced regressor technique, which is random forest technique. Random forest, which is itself in our classification, it is an ensemble technique in bagging, which shows 91% accuracy. So we could see here ki ridge rather than random forest, ridge regression is showing higher accuracy, which is 94%. We could see here ki without tuning it was 94%, and random forest regressor is showing the 91%. So it is very obvious. At last we could consider our ridge regression is our final model. So that is the only thing which I have done here for pickling itself. This is the again a visualization. After even after cross validation, random forest have not increased its accuracy at all. It is decreased to 90%. Now let's move toward feature importance. By this particular graph we could come to this particular conclusion that the feature low is the most important feature. And now what I have done, I have saved this this linear regression model, more specifically the ridge regularization linear regression model. I have saved this model in a pickle file in order to get that particular file in the future without affecting its tuning, we could say. And again we can see it was the train accuracy 97%. The train accuracy, the ridge regression was showing the 97% accuracy for training data set, and the same thing when we unpickled our pickled file, we got the same accuracy. So this is the advantage of pickling. So basically this was my Yes Bank linear regression project, where we have predicted the closing price of the Yes Bank stock, and we could see as a conclusion I have considered ridge regressor model as my final model if I have to implement it or I have to deploy it anywhere. So this is from my side. Thank you so much.